Having a look inside the bell itself, there's a couple of things we can notice. So obviously the bell, this can be wound up and down on a central screw pivot that's in there. We'll come to this later as regards faults and such. You have the two coils wide in series. You can't really get at them. It's one of the kind of the faux pas of the modern block bell instrument, that you can't really get in to see what's going on. The wire that comes off from this coil, the coil nearest the camera, actually loops up and goes into the X terminal, so that's nice and easy to see. The other wire you can't really see. What happens is it actually goes underneath the back of the bell. I can show you. It loops back round just down underneath the back of the block there to the back of the terminal. So that's a little bit annoying. You have the armatures of the bell hammer itself. So this is the center of the bell hammer, and it's attached to a large screw down there. Some of them are a nylon screw, some of them are metal. What you also have, I'll show you a picture in a minute, there's a flying braid that attaches the handle to the base to keep an electrical continuity, because obviously it pivots on the screw. You also have two sets of contacts. You have a top small spring contact and a bottom small spring contact, and these are a source of much joy for S&T engineers. Reason being, after many years, they either get pitted, they get burned, or you get fluff inside. I don't know if you can see that, there's actual dust in here. Now, there is a plastic plate that goes on the front of the block instrument to try and keep the dust out, and the door on the back, but it's not airtight, so you will get dust in there. That's one of the problems we have. Another couple of problems that we suffer with on the actual instrument itself are these terminals. These are very fine brass terminals. An electrician's screwdriver is just perfect, but this is a learning curve. I don't know if you can see this. Can you see the block above? It's well placed to be right in line with the block below. So when you're trying to get your screwdriver in, you need a very small Chubb screwdriver. That's a bit of a poor design in my opinion. Another problem you will find, the plastic plates, the Perspex plates and the screws that go over them, go through there. Once they've been sat in for a few years, it's an absolute nightmare getting those screws out. The plates start to crack, as you can see there. The other problem is, once it's on, you can't check those wires are tight without pulling them. So these tend to be dispensed with, ironically, so that engineers can actually get in at these. A little bit of a redesign would have been better. Again, this is only the bell instrument we're contracting on, but as you know from previous videos, screws that hold the different units of the block bell together, they're also the electrical connections, and when things go loose, you lose your electrical connections, and that's a source of much joy for engineers as well, trying to find those faults. So a couple of faults you can get easily on the bell itself. First one is a dirty contact, pretty obvious. You can find that out very easily. The second thing you get is this small screw at the top here, that small screw there, comes loose and starts to work its way up or down. That's really annoying. It shouldn't do. It should stay there, but it can happen. The third thing you can get is you start to get people winding the bells up and down because the bells don't make right. Now, what happens there, I'll have to turn the bell around to show you. In fact, I will actually, I'll show you the front. This is the front of the bell. Now, if you look very carefully at the actual striking hammer itself, you'll notice something. You'll notice the screw thread is towards the bottom and the top of the hammer is upwards. What I tend to do is I tend to get a pencil or a pen, and I'll put a little mark on there, because people interfere with these. They twist them and they turn them. And they don't realise that, yes, that's a locking nut on the front, but there is also a locking nut on the back. If you start to twist the whole of this hammer, all it's doing is it's putting stress on the back. And what will happen is it'll shear off. We've had quite a few of them go over the years on the national network, because people just, I'll just adjust that a little bit, snap. So by all means, if you have to adjust this, small pair of pliers on the back, undo the locking nut, rotate it, mark it, yes, I'm happy with that. Tighten the nut up, but don't just go twisting the whole of the hammer assembly, because it will snap the back off. It's so easy to do. I mean, just look at the play on that. You know, it does get loose after a few years. That usually will account for various thuds, and it's not making a good bell sound. Another one is this. People start to screw it up. So it's hardly striking, really. I wonder why. Because your bell's miles away. But again, that has been known. So that's wound all the way down. And I can tell this one's been adjusted in the past because it's actually touching the bell now. So that will just go dunk. It won't make any difference at all. There you go. So if I wind that up a bit, give it a little bit of a gap, only a little bit of a gap. So you can see. I have to wind that all the way up to get a good clunk. Now that tells me this has been adjusted or been played with in the past. What you will also find, people do this, get a pair of pliers, long nose pliers on there, and they'll bend this up. And that's because there's been problems at the back. Someone's been playing with the back and adjusting it. You can see here the flying lead I mentioned. This is a piece of braided wire. It's normally copper or brass, soldered on to the armature, and it goes back down to a little stud there on the bottom to support, and then it goes off around the back. You'll notice on this one, the spring's missing. This is an old block instrument. The spring's been broken off something, so it's been borrowed off this one. We have actually ended up making these before now. You can do it the old-fashioned way, a piece of brass wire, the centre out of a pen, wrap the thing around it, and you'll make a temporary coil while you get one repaired. It does have a fixing screw that's been taken out as well. And again, if this nut here starts to come loose and doesn't have enough spring tension on it, it won't return the armature back quickly enough. And again, we found solutions to that in the past where we've ended up using Telecom's battery terminals. The NIRL terminal off the top is exactly the same. So that'll do as a temporary replacement. So that's another thing you can do. You notice the amount of dust in there? That's literally only a few weeks dust. So you can see some of the problems you'll get. One of the tricks we can do sometimes is just ring our own bell, and we do that by shorting out the back contact. So I'll show you that now. So normally what I would do, if I went behind the back of the block shelf, I would see if our bell's working. Now you can get the signal at the other end to hold his hammer down or press the hammer a few times, but invariably he's going to be quite busy and he's going to get very annoyed with you, constantly ringing him up to try the bell. So the old trick we used to do, you short your own contact out, you short your top contact out on the bell, and it rings yourself. Now the way I've got this configured here, I haven't wired all the wires up together, but if I break my contact and short my own top contact out, I'm ringing myself. That's great for testing. You can have a play around with it then. You're not interfering with the signal at the other end. The only thing you do have to tell them is that their bell will be ringing as well. Please ignore it, because it will ring and it will ring and it will do their heads in slowly while you're doing this. But at least you can test your own bell there without having to mind the guy at the other end, several miles away. One of the things we always thought about, why didn't they do this? So the hammer armature inside there is on a pivot, which is that screw that I mentioned, attached to the base. You can't easily get these apart. What you have to do is flip the whole unit upside down, take all the screws out, and then slowly dewire it, and it will come apart and you can get everything out. Not the easiest thing in the world. Why didn't they just make a small hole here so that you could get a long screwdriver in, take the screw out, and then you could take the armature out, replace the armature. Ironically, I think the Hornby Junction bells, the ones used for the training centres, actually have been redesigned with this in mind. And another issue we have, it's very breakable plastic. It's so thin, it's so easy to break. Again, the Hornby Junction ones, they don't have that issue. They're a modern moulded plastic. They're a lot tougher. So, lovely design, loads of engineering issues that should have been redesigned out over the years. The terminal blocks shouldn't be in line. The bottom one should be stuck further out so you don't have any issues with screwdrivers. Because bear in mind, there's another block going on here, which is this one. So by the time that block is sat on there, you've no chance of getting a screwdriver at them terminals. A redesign of these terminals to make them slightly bigger would have been better. People use the wrong screwdrivers. They do break the brass nuts, and once you've done that, yeah, that's a problem. It's changed the whole thing. And again, soft, hard plastics, different uses there, and little things like holes on the side to get screws in and out to make it more modular. The old blocks were easily repairable in the workshops. These are repairable, but they're more plug and play and throw away. That's how they were designed. Oh dear, block instrument's broke, I'll just get a new unit. Now that would have been fine in the 1950s, 1960s, but they're becoming harder and harder to get hold of. And we're going slightly back to a modular design when these are built into panels. So it does need to be, you know, kind of thought about the engineering of how to repair things. And again, staff competencies. Taking one of these things apart, I understand what I'm doing, but that's on a heritage railway on the national network, we change the block. That's what we do. And we are starting to see lots of issues as well. Brass dust, quite a lot of brass dust. I've seen blocks in use for 40 years and very little brass dust in them. And just recently we've seen quite a lot with a lot of brass dust in them. So maybe that's the component parts. There are little things to keep an eye out on. Keep an eye out on the contacts at the bottom, as I mentioned, and keep an eye out on the actual hammer and armature. I mentioned that little locking nut, not easy to see. See if I can get that at it for you. It's just in there, just behind. I'll zoom in on that. If it'll let me. You can't really see it, but there's a locking nut just there on the back. That's what everyone forgets about, and that's why these shear right there at the back. Now you can get the back out, providing it's poking through. There's a little bit of a screw there poking through, so you can work that out. There should be enough of the thread left on the old armature to be able to rethread it in. It will make more of a thunking sound because it's brought the hammer closer into the bell, but you can rethread that to get in emergency to get it going. Testing the coils, obviously you can do that once you disconnected the wires off the blocks, so that's easy to do. One thing to note, again, differences in the bells. There is a bell unit just for normal use between signal boxes, and there is a bell unit for the end of a line that uses repeater BXRs. That wiring is very slightly different in there. Again, you'll work it out very quickly when the bell doesn't work, and you'll see the diagrams and go, it's a slightly different modification. You have to be aware the label on top of the bell unit tells you the type of bell. So, you know, unit number 1, unit number 8, etc., all the way through the block instrument. There's a drawing that is on the system for that, and I can provide a picture of that in a minute. So make sure you get the right one. But it has been known that we've had to rewire the cross that's in them, where we found that this is a bell unit for somewhere that's repeated with BXRs, and it turns out it isn't. It's now being used on a single line at the end of a junction somewhere. So there are variations of things that have to be checked. Again, that's the internal wiring, not the external wiring. The external wiring is to diagram. The internal wiring is done in the factory. So just be careful of things like that. Things do get altered. It's XB, X and XL on the terminals. We'll go into that in a minute. XL, bell line, X and XB the positive feed. So we'll go into those kind of details in a minute. And lastly, one other fault that we have had in the past, even though these are beautifully soldered, wires do snap off. They get brittle and they snap off. They're usually up on top of a block shelf. It's nice and warm for their whole life in the signal box, and the wires do get brittle and pop off. So that can happen. The worst one you can get is the wires down the back here, because you can't get at them without taking the whole blocks off. And that's dropping the block off, turning it upside down, getting the screws out and pulling the whole thing out. There's very little wire to work with. One more thing to mention is this small unit item down here. This is a little spring return buffer. So when you press your hammer down, it doesn't go all the way down to the casing. There's a little spring in there and a little piece of Bakelite that acts as a buffer. That can get worn over time. Generally, I've not had any problems with these ones, They've been in since the day dot, and you can get at the parts by going underneath once you've got it all separated out. And there's a little screw terminal there that pulls itself out. That's pretty easy, should be all right. You shouldn't have any problems with that. As I mentioned, it's a bit of hard Bakelite, so you should be fine with that one. I couldn't do a video on block bells without showing you this bell. Now, it's not in its wooden case. That wooden case we don't have, unfortunately, but it's a beautiful example, and I thought I'd just take you through this. Very similar, exactly to the insides of the BR standard block bell. You have your metal base plate, you have your armature upon which the striker hits the bell, in this case underneath the bell. You've got your vertical pillar that holds the bell, and you've got an adjustment screw at the top. A couple of other things on this one. These are cloth wrapped coils. Paper wrapped coils. The other ones are laminated cloth wrapped coils on the BR standard block bell. Some beautiful and very delicate enamelled wire coming off there. It was in a right mess when we got it, but it's also got the series winding between the two coils. And you'll notice it's got a couple of things on here. It has the backstop here in this case, so you can adjust this screw in and out as a backstop. A little locking screw there to release it, so you can tighten it in and out. So don't forget that's there if you have to do, the old wooden bells. They do have locking screws, not always obvious. And I think at some point this one has probably been a trembler bell, because you'll notice there's a contact there as well, just hidden in there. Now that trembler bell, obviously, as the armature breaks to hit the bell, it will break the contact, it will then lose its power and fall back. Remaking again, breaking, making, breaking, so forth and so forth. So I think it has been a trembler bell at some point as well. But just give you an example, very low voltage, very low current. Dead easy to use. It's only a couple of volts, that. Noise is quite a little bit tinny. I dare say this wants a slight bit of an adjustment. And you go, it's getting better and better. So little things to look into. And you can change the cap domes on these as well for different sounding bells. That was obviously designed into the process, because when you've got a signal box full of bells, you need to know exactly which bell is ringing, and it does help if you get the right bells and mix. Oh, that's a heavy bell, that is. Little fibre washer on the top there to dampen the top. Notice the screw hole in the middle, it's square, so it sits upon the squareness of the shaft and doesn't rock around. It's actually located. And the washer back on. And the nilled brass nut back on as it should be. So I just thought I'd show you that, just as a last little piece, a beautiful bit of engineering. Just needs a nice wooden case now. Finally, we'll have a look at some diagrams. And this is one from Totley Signal Box that's now long gone, which shows a modified unit number 1, which is the bell unit. The wiring between the tapper and the bell unit itself has been separated out. But we'll have a closer look at the diagram just to explain a little something that you should all know about on the diagrams itself. So on common diagrams, you'll probably see something like this, and what you have is the BX, the block bell unit, X for bell, B for block, and you'll see a feed coming in from one side, or a return, and you'll see these contacts here, which are the tapper contacts of the actual bell hammer itself. Some places this will actually be shown as a relay terminal, and you can tell quite clearly because it'll have a number next to it, such as 1 and 2, etc. Normally with the tappers, you don't get that. Again, you'll notice this line off here, it actually goes off to the line or earth, and that's your incoming and outgoing line shared. And this is another supply. I've not shown which supplies they are, that depends. And again, a resistor will be added into there to prevent the line current being too excessive and damaging the equipment at the other end. But in essence, what will happen is you should not be able to ring both bells at the same time. That should not normally happen, because as you operate the tapper, you'll see you'll either make one contact or make the other. So for instance, you will have, with the tapper not pressed, gravity will pull this end down, pull that end up. So this is where you need to be careful with these contacts, because that does not represent normally that contact made, because that is the contact at rest. Contact at rest. When I press the tapper down, this will go up and make. So as you can see here, this contact would make if you were to press this, but that would then ring your own bell. Hence why when we short our own bell out, our top contact, it rings our own bell, and also his end, because we're shorting things out. So this is already made and we've shorted that out, so we end up ringing both bells. So in reality, when we press the tapper down, we allow a feed over the resistor, through this contact and out. This contact, of course, in the same tapper as this, breaks this contact, because you can't have them both made at the same time, so you prevent yourself from ringing your own bell. So you can't both be ringing bells at the same time, otherwise you'll miss the beat, but more importantly, you can't do it anyway. You have to have one not made and the other end sending made. So when you press, you send your own feed out to line, but break your own feed so you can't ring your own bell. And when the other guy presses at the other end, again, you're not pressing, prevents that shorting itself back out and allows it through to its own bell. So just be careful, these contacts here do not necessarily represent contacts as viewed on the back of the unit itself. What we are used to as a front and a back contact, and these contacts is different. This is more the telecoms side of the circuitry that is referring to contacts on. So you just need to be aware, this is the lead into the bell, is a contact when you are not pressing your own tapper down so that they can send to you. And this is the contact when you are pressing your own tapper down so you can send to them and break your own feed so you can't ring your own bell. So that's just a little bit on wiring diagrams. They are all wired differently, so just keep an eye on what you've got locally.